In 1998, researchers confirmed that the human cerebellum sends direct signal loops into the prefrontal cortex, the seat of reasoning, judgment, and decision-making, not motor signals, cognitive ones. And neurologists still cannot account for why that finding never made it into a standard anatomy curriculum. Something was deliberately left out of your education. Your brain weighs about 3 pounds. Most of what you were taught about it fits inside a paragraph. The cortex thinks. The hippocampus remembers. The amygdala fears. And at the back, tucked under everything else, the cerebellum coordinates your movement. That was the consensus. That is what every anatomy course, every neurology textbook, every medical school curriculum agreed on through most of the 20th century. The cerebellum, Latin for little brain, sits at the base of your skull. It accounts for roughly 10% of the brain's total volume. It was mapped, cataloged, and filed neatly under motor function. The case was closed, except the numbers never added up. Here is what they didn't put in the textbook. The cerebellum contains approximately 69 billion neurons. The rest of your entire brain, the cortex, the limbic system, the brainstem, all of it contains roughly 16 billion. That means the structure you were taught manages only balance, and movement holds 80% of all neurons in the human brain. 80%. You would not build something that complex to help you catch a glass before it falls. Evolution doesn't work that way. Structures with that kind of neuronal density are doing something that requires that level of processing power. Researchers had this number by the mid-20th century. It appeared in peer-reviewed literature. It was available. And for decades, nobody updated what got taught to the students who went on to practice medicine, treat the mind, study cognition. The explanation most people reach for is simple. Science updates slowly. Textbooks lag research by years. Committees revise curricula on long cycles. No conspiracy, just institutional inertia. It's reasonable. It's the kind of answer that closes the question before you ask the next one. It would hold if the researchers publishing the neuron count data hadn't also been publishing something else at the same time. Something the inertia theory doesn't touch. They were publishing the connections. As early as the 1970s, laboratory studies in primates were documenting cerebellar projections that had no business being where they were. Fibers running not into the spinal cord, not into motor relay stations, but into the dentate nucleus, then into the thalamus, and from the thalamus directly into the prefrontal cortex. The prefrontal cortex does not handle movement. It handles planning, judgment, working memory, abstract thought. That circuitry was documented, peer-reviewed, and published. By 1998, imaging studies in humans confirmed it. Cerebellar damage in patients with no motor symptoms was producing measurable deficits in language, in emotional regulation, in the ability to sequence future actions. Clinicians gave it a name: cerebellar cognitive affective syndrome. The syndrome existed. The data existed. What didn't exist was the update to what got taught. Here is where it gets harder to explain away. Neuroimaging research in the early 2000s began mapping the default mode network, the system active when you are doing nothing, simply existing, daydreaming, constructing your sense of self. The regions involved: medial prefrontal cortex, posterior cingulate angular gyrus, and the cerebellum. The structure you were told manages your posture is active during self-referential thought, during memory consolidation, during the construction of the internal narrative you call your identity. In 2019, a paper in Neuron documented direct cerebellar involvement in social cognition, the ability to model other people's mental states, theory of mind, the thing that makes you human in the most specific sense. Researchers have since documented cerebellar contributions to language processing, to anxiety, to addiction pathways, to the timing and prediction systems that underlie every social interaction you have ever had. Every year the list extends. None of it is in a standard anatomy course. Medical students still receive the same paragraph. The cerebellum coordinates movement, 80% of your neurons. One paragraph. The inertia excuse fails on timeline. By the 1990s, this was not buried in niche journals. It was being presented at major neuroscience conferences. The Society for Neuroscience was publishing it. The ceiling was not complexity. Medical students learn the full limbic system, the subtleties of dopaminergic reward pathways. They can handle nuance. Some researchers have pointed to something subtler: professional investment. Neurologists had spent careers on a clean division of function. Movement disorders were cerebellar. Cognitive and emotional disorders were cortical. Revision threatened diagnostic frameworks that entire subspecialties had been organized around. Not a conspiracy, but something closer to a collective decision not to look too carefully at what the numbers were already saying. You were taught that your cerebellum keeps you upright. You were not taught that it may be one of the primary structures constructing who you are. The neuron count has been in the literature for 60 years. The only question left is what else didn't make it into the paragraph.